This is the video for corn mash and distillation. Ethanol is a renewable fuel source that is primarily made from corn. The starches in corn must be broken down into individual glucose molecules. This lab allows students to ferment and distill their own ethanol. To prepare samples for fermentation, you'll need a 250 milliliter Erlenmeyer flask or a 500 milliliter filtration flask, 50 grams of ground corn, at least 50 milliliters of distilled water, and a stirring rod. Begin by adding 50 grams of ground corn to the flask. Then add 50 to 100 milliliters of distilled water. Then use a stirring rod to mix completely. The mash will then need to be heated, which is best performed using a water bath, which will prevent the sample from scorching. When the water bath is boiling, use a ring stand and utility clamp to gently lower the sample into the boiling water for at least 10 minutes. Students may want to test this boiling time as a variable in their experiment. It is very important to allow the sample to cool to room temperature before adding enzymes or any yeast. Failure to do so may denature the enzymes, preventing them from working. After enzymes and yeast have been added, distilled water should be added to thin the mixture and dilute any ethanol that is produced. Stir again after water is added. Now cover the sample with saran wrap and a rubber band, or if collecting gas, use a stopper with tubing that will allow the bubbles to be collected. To measure the amount of carbon dioxide produced, you'll need a graduated cylinder or other plastic jug that you can see through. You will also need a pan to fill with water to invert it into. Fill the container with water, then cover the container and turn it upside down in the pan of water. Position the tubing coming from the sample so that any bubbles will go into the container. Now, as carbon dioxide bubbles are produced by the yeast, their volume can be measured in the graduated cylinder. When fermentation is complete, record the amount of carbon dioxide collected. This can be used to estimate the amount of ethanol produced. To prepare for distillation, the sample will need to be run through cheesecloth in a strainer to remove solids from the mixture. The cheesecloth can be picked up and squeezed to remove as much liquid as possible. Save the solid mash for nutrient testing. Distillation is a method for separating components in a mixture using their different boiling points. The yeast used in fermentation can only tolerate a mixture of about 20% ethanol. In order to purify the ethanol, we will heat it to its boiling point of 78.4 degrees. At this temperature, the ethanol will be boiling and the water will not. However, some water will be evaporating. Condensing the vapor being driven off will produce a much higher concentration of ethanol. To set up a distillation, you'll need a mantle, distillation flask, a condensing tube, and a distillate receiving flask. In this animation, you'll see that the mantle is used to heat the sample to boiling. The temperature of the vapor is monitored and should not be allowed much above 80 degrees Celsius. The vapor is then cooled in the condensing tube and collected in a distillation receiving flask. We have found that setting up the distillation apparatus with the mantle raised so the condensing tube can be in a vertical position has allowed the corkscrew and the condenser to drain properly. This has increased our ability to produce flammable ethanol in the distillate. In my classroom, I have students use GoTemps and Logger Pro to record the temperature during their distillation. You can see the area at the top of the graph where the temperature remained constant at 80 degrees Celsius. This indicates a successful distillation. If you perform the gas collection procedure and have a good idea of how much carbon dioxide was produced, we can use that amount to estimate the amount of ethanol. For example, if 3.5 liters was produced, 1 mole of gas is about 22.4 liters, and 1 mole of ethanol is 46 grams, and 1 milliliter of ethanol is 0.789 grams. We would estimate a little over 9 milliliters. Once the distillation is complete, the density of the distillate can be used to estimate the percentage of ethanol. First, record the total volume of the distillate, then mass a 10 milliliter graduated cylinder. Add less than 10 milliliters of distillate to this cylinder and record the volume. Mass the cylinder and the distillate, subtract, get the mass of the distillate. Now that you have the mass and the volume, you can calculate the density. Now that you know the density, you can use the graph provided or find a calculator online to estimate the percentage of ethanol in the mixture. In this case, 8.99 grams per milliliter would come close to about 57% ethanol. Record this in your data table and multiply this percentage by your total volume of distillate to find out how much volume of ethanol you actually collected. You can compare this amount with the amount you estimated using the gas collection procedure. If your ethanol percentage is over 30%, it should be able to sustain a flame in a flame test. Add a small sample to a watch glass and remove all the flammable material from the area. Use a lighter to light the vapor coming off of the distillate. You should observe a clean burning blue flame. You may need to turn down the lights.